Hi all, so in the previous video we looked into the basic definitions of what you mean by velocity, what you mean by acceleration, what do you mean by displacement and its corresponding terminologies. For solving a problem, you need to have some basic equations. All those equations are more than enough to solve a problem that is required for engineering mechanics. So without any delay, we'll get to the equations. So these are the three basic equations. Basically, you can find four equations, but these two terms are basically can be combined, are just one and the same. Okay, so these are the these are the equations that are very necessary to solve a particular problem. Okay, so the first one is V is equal to U plus AT, which means V corresponds to the final velocity, and obviously you know that U corresponds to the initial velocity, A corresponds to the acceleration of the body, and T corresponds to the time taken. Basically, this time taken is where it starts from U and it ends with V. So this is the time taken that is present in this equation. So V is equal to U plus AT. Another equation that is very important, so consider this as equation 1. Another equation that is very important is this one. S is equal to ut plus half at square, right? Obviously here S corresponds to your displacement, right? And u is your initial velocity, t is the time taken, and half, obviously it is a constant, and a corresponds to acceleration, t again reappears. Over here, please note the point, this particular t corresponds to the time taken, which means time taken for a body which has initial velocity u and it reaches the final velocity v, whereas this particular t corresponds to the time taken to complete displacement. Yes, okay, so this is very important. Both these time, of course it is referred as time taken, but this particular time which appears over here is the time taken for the body to have an initial velocity and then ends with the final velocity, whereas this particular time taken is a little bit different. For completing a distance, what is the time taken, that has to be considered, and the final one is v square plus v square is equal to u square plus 2as. So this becomes the third most important equation. Okay, so without no further delay, we'll get into the problem. Okay, so here we have a problem. Let me just read the problem once again. A burglar car had started with an acceleration of 2 meter per second square. A police party came after 5 seconds and continued to chase the burglar's car with a uniform velocity of 20 meter per second. Find the time taken in which the police party will overtake the burglar's car, right? So this is a little bit complicated. Just follow the problem. You will be able to understand it very easily. Fine, right? So first, I'll consider t as the time taken for the police car to overtake the burglar's car. So first, I have to find out the distance traveled by the burglar's car. For that, the basic equation S is equal to ut plus half at square. Fine. So every car, whether it's a burglar's car or even a police van, a police car, basically the initial velocity will be equal to 0, right? So u is equal to 0. So this whole term will be 0 plus half 2, which you can find it over here. Your acceleration is 2 meter per second and t plus 5. Why this particular t plus 5 has come into picture is, here you can find this. A police party came after 5 seconds of the burglar's car, which means the burglar's car has started 5 seconds before it. Let me just reframe it. Police car has started at time t. Your burglar's car obviously should have started 5 seconds before it. So this is taken from this particular statement. Okay, so this particular statement has given to this particular value. Okay, so now you can just substitute it. Here you have s is equal to t plus 5 square. Again use the same equation for the police car. So distance is equal to velocity into time. Very simple. So s is equal to 20t. You have equation 1, equation 2, solve it. You are going to get what is the value of your what is the value of your time. Okay, so basically it is 5 seconds, right? So with this particular problem we'll wind up for this particular video. Again, first look into the problem, take those three equations into consideration, and then try to solve this particular problem. It will be very easy to solve and then find out the answer. Thank you.